Hi everyone. In this module we learn the Mossbauer spectroscopy. In this module I am going to discuss with MSc 4th semesters Chemistry, Karnataka State Open University syllabus. In this unit, we have to discuss the concept of Mossbauer spectroscopy. Under that, introduction, recoil effect, conditions for Mossbauer spectra. Iron is the most studied precursors recording the Mossbauer spectrum. Isomeric center or chemical shift values for iron compounds, electric quadrupole interactions, stereochemical activity of lone pair, magnetic interactions, applications of Mossbauer spectra, study of thermal spin crossover, and summarize that unit. In this Mossbauer spectrum, generally we have to use gamma rays. If a nucleus gives off radiation or any other form of energy, the nucleus must recoil with an equal and opposite momentum to preserve its energy, in the same way that a gun recoils when a bullet is fired out of it. We describe this general case in terms of energy by saying that energy of gamma rays emission is equal to the energy of transmissions and energy of recoil. Here iron 17, which is a decay product of cobalt, is unstable. Iron 17 decays by giving off a gamma ray along with other types of energy. Just you see that figure. It is the scheme for cobalt to iron by various back scattering process for iron that can follow resonant absorption of an incident gamma photons. This is what source, this is absorber, these gamma rays, various energies, this is takeoff electrons, these are what different Uger electrons. This is the emitted following resonant absorption. This is non-resonant. From this figure shows a schematic of vibrational energy levels in a solid. On the left, the recoil energy of an emitted gamma photon is less than what is needed to reach the next higher energy level. So that excitation of a vibrational mode has low probability. The probability that has no excitations will occur is given the symbol F, which represents the fractions of recoil free events. Just observe There is electron in that lower energy state. This is what frequency. This gamma ray would be emitted without losing energy to the solid in what is called zero photon transition. In other words, sometimes the nucleus absorbs the energy of gamma ray and it does not recoil. The variable F indicates the probability of this happening. This process of recoil, less emission forms the basis for Mossbauer spectroscopy. Just we consider on right here ER is significantly greater in energy than the lowest excitation energy of the solid, which is En plus 1 minus En. The absorption of the recoil energy by the solid thus becomes probable and the photon emerges with energy reduced by ER with Doppler broadening. This is what Doppler broadening. The Mossbauer effect occurs because in solids the value of F is high enough that recoil-free absorption is possible. Thus, an atom of cobalt can decay to iron, which gives a gamma ray and may be absorbed without recoil by nearly iron 57. This is what relative velocity of this. This is what free atom. This is the values of this. This is hyperfine splitting. What is meant by recoil effect? Whenever high energy particle or projectile is released from a body at rest, the releasing body feels a back kick, that is, it is pushed backwards. This is true for absorption of high energy particles also. This phenomenon is called recoil effect. The recoil happens to conserve the momentum. When a gaseous atoms or molecules emits a quantum of energy, capital E, then emitted quantum will always have the momentum E by C, where C is what? Velocity of light. Just we have to written here to conserve the momentum of emitter recoils with momentum P, which is equal and in opposite direction. P is equal to M, VR is equal to minus E by C. Here VR means recoil velocity. The negative sign shows that direction is opposite. This ER is equal to P square by 2M. Here E square by 2mc square. This is what? Recoil effect. What are the conditions for Mossbauer spectra? The energy of nuclear transition must be larger enough to give useful gamma radiation per photon, but not enough to cause recoil effect. The energy of the gamma ray photon must be in the range of 10 to 150 kilo electron volt. A substantial amount of nuclear decay must have with gamma rays. The lifetime of the excited state must long enough to give a reasonably broad emission range. These are all what important conditions for this Mossbauer spectrum. Here, iron is the most studied precursors. The precursors of 50 iron is cobalt, which decays to iron with half-life of 270 days. 9% to 57 iron decay to ground state directly with emission of gamma ray photons of energy 136.32 kilovolt. Here 91% of iron decay, another excited state with emission 121.9 kilo electron volt energy. The lower the oxidation state is having half-life times of 99.3 ns. This decay to ground state with emission of 14.41 kilo electron volt. This transition satisfies all the conditions of Mossbauer spectra except second condition, but this is compensated by large absorption cross section. The other elements can be studied SN2 plus 119 SN, 121, 125 technetium, Radin is 129, xenon is 129, gold is 197. How to record the Mossbauer spectrum? Usually standard emitter is used as a source. Both the samples and absorber are emitted in a crystals, that is, to minimize the recoil effect. The source iron 57 spectrophotometry or spectroscopy is commercially available. The cobalt or rhodium is mounted on the shaft of a vibrator. The source is generally kept at room temperature. The absorber may be cooled down to liquid nitrogen or liquid helium temperatures. Next, isomeric shift or central shift or chemical shift. In that isomeric shift or central or chemical shift, ET values is affected by the interactions between the nucleus and the electron present around. This arises because of distinct sizes of nucleus in ground and excited state. The change in nuclear radius when going from ES to delta R. This is the formula to calculate that chemical shift or isomer shift. Delta is equal to E naught by Z, ZE square into R square. This is the mathematical expressions to calculate the chemical shift. Okay, here just we observed here isomer shift is related to oxidation state of the metal. in Stannis spectra shows positive shift with respect to Sn, whereas Sn4 is negative. This was Stannis 4, 5s0, 5p0, electron density oxygen decreases, so negative shift. Your electron density increased, P screening not present, so positive shift. Chemical safe values for Fe compound. The isomer shift of iron cannot be used to determining oxidation state of iron in a molecule. Fe shows oxidation state from 0 to 4 often diverse in unit charge only. The electrons involved a metal electrode, so effect on the S electron is smaller. Next we consider this varying spin states also affect the shift values. So some useful correlations had been drawn. Here iron porphyrin complexes are very important biologically. Iron can be present in +2 or +3 state in them. The complexes can be easily reduced. The electron may be to iron to the other ligand. In that ambiguous case, Mossbauer spectra is useful in determining the oxidation state. What are the electric quadrupole interactions? Nuclei in states with an angular momentum quantum numbers I greater than of a non-spherical charge distribution. This process a nuclear quadrupole moment in the presence of a symmetric electric field. This split in the nuclear energy levels. The charge distribution is characterized by a single quantity called electric field gradient. In case of an isotope with I is equal to 3/2, excited state such as iron 17 and Stannis 119 has been the magnitude of splitting delta is related to the quadrupole, nuclear quadrupole moment. Q is the principal component of AFZ by the reaction. This is quadrupole splitting for Fe 57 to Fe 180. This is all that splitting. Based on the selection rule for MB spectra, there is a schematic diagram of this. What is the information from this quadrupole splitting? The appearance of quadrupole splitting shows the presence of EFG The EFG may be created by the ligand field or by the electric distribution. Single crystals or applications of magnetic field gives more information. If a nucleus with symmetric electron distributions in octahedral field, EFG is not expected. What is the stereochemical activity of lone pair? Consider tellurium compounds with 6 ligands. If the lone pair of electrons of technetium is stereochemically high, then it will occupy one vertex of a pentagonal bipyramidal no quadrupole splitting is observed in these cases of compound entities. Hence it is clearly that lone pair is stereochemically inactive. Next we consider structure this tellurium complex had not been crystallography studied. The Mossbauer spectra of these species show no quadrupole splitting, but this is not conclusive evidence for absorbance of EFG. Next, magnetic interactions. In the presence of a magnetic field, the nuclear spin moment experiences a dipolar interaction. With the magnetic field, Zeeman effect or splitting. There are many sources of magnetic field that can be experienced by the nucleus. The total experience negatively charged. The total effective magnitude at the nucleus is given by the formula here. VFF is equal to B contract plus B orbital plus B dipolar plus B applied. These are also representations of this spectra. What are the applications of these Mossbauer spectra? Yes, spin, free iron sulfate. From the crystallographic data, it was initially concluded that hydrated ferrous salt is having a perfect OH symmetry with 2 water each vortex. But the Mossbauer spectrum recorded showed a quadrupole splitting which is not possible in a regular octahedral splitting. In case of iron, it is a D system. D system means in that iron totally 26, 2 plus means to remove 1 electron from 4s, 1 electron from 3d. Iron is a 3d system in a weak field created by water and orbitally generate system result. Thus, undergo ZT distortions, remove the degeneracy and a tetragonal field. This creates an EFG at the anode. At the nucleus and hence quadrupole splitting occurs. Hence, the structure assigned by the oxygen octahedral will be angles of 190. The Prussian blue and thermal blue. Prussian blue is a dark blue pigment with the Idealized formula, it is prepared by adding ferric salt to ferrocyanide. The Quadrupole blue is the same substance, but it is made from different reagents, addition ferrous salt to ferric cyanide. It is slightly different color systems from different impurities. For a long time they considered as a chemically different compounds. The Prussian blue with iron 2 C6 minus, that is anion, and Quadrupole blue with iron 3 Cn6 3 minus anion. According to the different way of preparing them, however, the Mossbauer were nearly identical for both P, B and TB, showing only one presence of FeCN6 4 minus and Fe3 plus in the high spin state. This was confirmed by use of potassium hexacyanoferrate and potassium hexacyanoferrate as a reference compound. This is iron 2 plus, this is iron 3 plus. Only 2 electrons. Here 4 electrons, here 2 electrons, here 6 electrons. Here 3 electrons, 2 electrons and single electron. The iron 2 centers which are low spin are surrounded by 6 cyanide ligands in an octahedral configuration. The iron 3 centers which are high spin are octahedrally surrounded by a average. The nitrogen atom and oxygen atom, nucleus and hence quadrupole splitting occurs. The sodium nitroprusside molecule, in that sodium nitroprusside, the oxidation state of iron in this compound, matter of controversy for a long time. Initially it was assumed that it contained Fe22 NO since it was diamagnetic. But the Mossbauer spectrum of the sample showed a doublet with this value is 2 negative of what? Iron 2 complex. This iron 6. Here D6LS complex with octahedral symmetry, whereas all the 6 electrons are accommodated in the 3T2Z orbital. Both contributions EFZ cell and EFZ norm vanish. There is no quadrupolar interactions. Consider this complex as a C4CV symmetry with d orbital splitting as shown here. Next we consider this ferredoxin. The study of ferredoxin, a FES protein which arises in 2 elements, arises 2 electron transfer reaction. The 2 iron centers are equivalent in the bond reduced form. These are some other examples regarding to that Fe3 plus and Fe2 plus. What is the study of this thermal spin crossover? Many coordination compound possessing intermediate ligand field strength show thermal spin crossover. For example, diphenyl iron cyanide disulfide undergo thermal spin transition. The main result is that in the temperature region, whereas mass spectra reflected on transmissions to the LS state by MES spectra still show the typical HS signals arising from field type. What is the summary of this image? Nearly 50 years ago, Rudolf L. Mossbauer derived the Recoil's nuclear resonance absorption of gamma rays, and it is referred as Mossbauer spectroscopy. It gives very precise information about the chemical, structural, magnetic and time-dependent properties of compound. The key features of this technique is the recoil's gamma ray emissions and absorption of a nucleus. Nuclei in atoms undergo variety of energy in energy level transition, and these energy levels are influenced by their surrounding environment, which can change or split these energy levels. These changes in the energy levels can provide information about the atoms, local environmental atoms within the system, and how to be observed using resonance frequencies. Here some following information regarding to that. Mossbauer. The hyperfine interaction between nucleus and its electron, small. Recoil of the nucleus as the gamma ray emitted or observed prevents resonance. Has nucleus, protons and neutrons is in contact with proton excited state of energy undergo transition of the ground state, emitted gamma quantum. The gamma quantum may be absorbed by the nucleus of the same kind in its ground state, whereby transitions to the excited state of energy E levels takes. The subsequent transition to the ground state emits transition electron or gamma quantum resonance fluorescence. These are all some important questions for your theory examination. What is recoil effect? Explain the necessity of Mossbauer condition. Next, why Fe is most abundant precursors in MB spectra. Explaining regarding of the MB spectrum. Isomeric shift, center shift, chemical shift or isomeric shift. Next, discuss the chemical shift values for iron to compound. And what are the informations about or obtained from quadrupole splitting? Okay, these are all important questions. Just to go through that. If any doubt, please put a or drop a message to me.